Greetings and salutations, and welcome back to 1 Less Than 3 Math. This is the next video in the 10 minutes 10 marks playlist. They are review questions of key areas of study that could appear in several exams. That could be your GCSE maths exams, it could be IGCSE core, it could be IGCSE extended, it could be in your Cambridge checkpoint exams, or it could be in your end of year 9 exams. They're all key topics. So if you'd like to have a go at these questions, please pause the video now before I proceed with the solutions and the explanations. So question 1a says write 172 and b48, it should say 248, but that doesn't matter, as a product of prime factors. So we're having to write 72 and 48 as a product of prime factors. Then part B, 1, we're going to find the highest common factor, and part 2, we're going to find the lowest common multiple. So first of all, we'll write 72 as a product of prime factors. Remember, 1 is not a prime number because it doesn't have two factors. 2 is the smallest prime number. So we always look with prime factors to see if we can divide by 2. Yes, we can. 72 divided by 2 is 36. We always circle the prime factor. So we then say, right, okay, which prime number can we divide 36 by? We can divide that by 2 as well. We get 2 and 18. 18 again divides by 2, and we get 2 and 9. Now 9 does not divide by 2, but it divides by 3. And 9 divided by 3 is 3. And when we get two cherries like that, two prime numbers, that's where we can stop. So we can write 72 as a product. Product means times, remember. So 72 equals 2 to the power of 3, because it's 2 times 2 times 2, times 3 times 3, so 3 squared. So 72 equals 2 cubed times 3 squared. So then we're going to write 48 as a product of prime factors using the same method. 48 divides by 2, we get 24. 24 divides by 2, we get 12. Every time I get a prime number, I circle it. 12 divides by 2, I get 6. 6 divides by 2, and we get 3. And when we get the two cherries like that, the two prime numbers, that's where we can stop. We've got 2 times 2 times 2 times 2 times 3. So that's going to be 2 to the power of 4 times 3. So that's part A done. Now we move on to part B, where we need to find the highest common factor. Now the highest common factor, you've got to multiply the pairs of primes, the prime factors that they both have. So let's see which ones pair up. 2 and 2, so we write 2. 2 and 2 again, so we write 2 times 2. 2 and 2 again, so it's now 2 times 2 times 2. And also a 3 pairs up, so it's 2 times 2 times 2 times 3. That would simplify to 8 times 3, which is 24. So to find the highest common factor, you've got to multiply the prime factors that they both have. Now, moving on to the lowest common multiple, we're going to multiply the highest power of each prime, the highest power of each prime factor. So that would be 2 to the power of 4, because that's bigger than 2 to the power of 3, and 3 squared, which is bigger than 3 to the power of 1. So we do 2 to the power of 4 times 3 squared, and that equals 16 times 9, and that is 144. And that's the lowest common multiple, the first number that is in both times tables, if you were to list the multiples. You could also do it like that, but multiplying the highest power of each prime always works. Okay, just as multiplying the pairs of primes for the highest common factor also works. Always. So question 2. Find the nth term of the following sequence. We can identify that this sequence is linear because it's going up in the same amount every time. It's going up 6 every time. So because it's going up 6 every time, we write down 6n. Now, we need to then subtract 6n from our sequence to see what else there is. 9 take away 6 is 3. 15 take away 12 is 3. In fact, it's 3 all the way through. So our nth term is 6n plus 3. I don't know why the 3's are slightly off there in the formatting, but it doesn't matter. You can see that 9 take away 6 is 3. Because it's a positive 3, it's going to be 6n plus 3. So the 100th term, we use the nth term, 6n plus 3, and we do 6 times 100. because of 6n plus 3, and that is 603. That's part B. And part C, is 304 a term of the sequence? Well, what we can do is we can use our nth term and we can set up an equation to see if it gives a whole number answer. If it does, then 304 would be a term in the sequence. So we'll solve this equation. We'll take away 3 from both sides. We get 6n equals 301. Now you can gather at this point that it's not going to be a term in the sequence because 301 is not a multiple of 6. But if we divide it by 6, we get 50 and 1/6, which isn't a whole number, and we can't have an n in a sequence where n is not a whole number, because you have your first term, your second term, your third term, n equals 1, n equals 2, n equals 3. So the answer to part C is no. Obviously, you need to show you're working out. So I've just moved that accordingly so it looks a bit nicer, but that would be the working out that you would need to do for question 2. So, question 3, simultaneous equations, personal fave. Now, the first thing we do is we make the y's move. We create the same number of y. So I look at 4y and 3y, and I think, right, what's the lowest common multiple of 4 and 3? Well, it's 12. So I'm going to multiply the top equation by 3 and the bottom equation by 4, so that both equations have 12y. So, first equation is going to be 9x plus 12y equals 30. I've times 3x by 3, 4y by 3, and 10 by 3 to create my new equation with 12y. My second equation, I'm going to multiply it by 4. I get 8x minus 12y equals 72. So now I've got 12y. I now go to my question. I get my simultaneous pizzas from the same signs takeaway. So I say, is this the same signs takeaway? And when I'm talking about the same signs, I'm talking about the signs on the y. Now we look at it and we've got plus 12y and we've got minus 12y. So they are not the same signs. So in this case, we're going to add the equations together because they're not the same signs on the 12y. So if we add plus 12y, add minus 12y, it eliminates the y. So 9x add 8x is 17x, 30 add 72 is 102. Therefore, to find x, we do x equals 102 divided by 17, and that equals 6. Now, if you were struggling to do 102 divided by 17, you could list the multiples of 17, and you can see that it is the 6th multiple. So now we need to substitute into our simultaneous equation. We can pick one of them. I always pick the first one that doesn't involve negatives. So 3x plus 4y equals 10. We now know that x equals 6. So we can rewrite that as 18 plus 4y equals 10. Subtract 18 from both sides. So 4y equals minus 8. Divide by 4. We get y equals minus 2. So our solutions are x equals 6 and y equals minus 2. Now question 4 says find the missing angles x and y. Usually this question would say explain why as well, give a reason why. So when you've got parallel lines, you can see that this is a parallelogram denoted by the arrows on the pairs of lines. We can use our angle rules within parallel lines. Now there's two rules, and the first one is z angles, and this is going to enable us to find angle x, because we can see that we've got z angles there, and 83 degrees and x are equal because alternate angles are equal. So alternate is the key word. When you've got your z angles, alternate angles are equal. So we can identify that x equals 83 degrees. Now y, we can now use x to find y, and this time we can identify an f angle. Okay, it's an f on its side, but still it's an f angle. X and y are consequently going to be equal. So if x is 83, y is also going to be 83, and this time it's because corresponding angles are equal, and that's the reason that you need to give. So the z angles are alternate angles, the f angles are corresponding, and these two words are the crucial words in these questions. So although this video is called 10 minutes, 10 marks, That's just the playlist name. You'd probably get about maybe 6 marks for the first question, 6 marks for the second question, 3 marks for the third question, and 4 marks for the second question. So plenty of marks there, up to 22 marks, I think, if I've added those numbers I just blurted out correctly. So anyway, hasta la pizza, arrivederci, so long, goodbye. I hope you've enjoyed the video. Please subscribe if you haven't already, and there'll be more videos coming soon.